Welcome to this M1 video on momentum in one dimension. So the momentum of a body is basically its mass multiplied by the velocity in which it is moving at. And it's a vector quantity because the velocity is a vector quantity. So momentum is mv, the mass times velocity. And if we look at the units of it, that would be its kilograms meters per second. Okay, but this isn't how we generally use the units of momentum. And that is simply because if we look at the units of force, so force is MA, and the units of that is kilograms per meters times meters per second squared. Okay, so if I take, this kilograms meters per second squared and times it by S, I'll get this. Okay, kilograms meters per second. Okay, and this is a Newton. So this one becomes Newton's seconds, a Newton second. And that is what we measure momentum in. So momentum is mv and it's Newton seconds. So if I had, say, a car weighing 1.5 tons, traveling at a velocity of, say, 0.5 meters per second, the momentum would simply be mass times the velocity. Okay, so 1.5 tons is 1500 kilograms. So this would be 1500 kilograms times 0.5 or 750 Newton seconds. And that is basically momentum. Now let's look at something else, something called impulse. So impulse is when a constant force acts for like a defined amount of time. Okay, so it's basically, well, I'll put the formula down. Impulse is force times time. Now, some examples of impulse is like, kicking a ball, punching a punch bag, hitting a baseball, with a bat, hitting a snooker ball with another ball. Okay, these are all examples of impulse. Now, in terms of what you kind of describe it as, it's basically described as the change in momentum. So when I was talking about momentum earlier, okay, if you think about momentum is that kind of force that's being built up. And, if you think of, two objects like a bowling ball and a tennis ball rolling at the same velocity, the bowling ball has more momentum because it's a greater mass. And then when either of these balls maybe hits another object, they have a change in their momentum because there's a change in the velocity. And that change in momentum is then the impulse that's acting upon the ball or upon the wall or the other object that they hit. Okay, so let's look at how we get to that change in momentum formula. So if I start with V equals U plus AT and rearrange to make A equals, and A the subject, so it's V minus U over T. Okay, And then if I substitute that into F equals ma, I get F equals m times v minus u over t, like so. So if I multiply by the t, I get ft on the left, and I get mv minus mu on the right when I expand the bracket. So multiplying by t and then expanding the bracket. Now this ft is impulse. Okay, and mv is momentum, isn't it? So in terms of v and u is the initial velocity and v is the final velocity. So this means that we have impulse equals final momentum minus initial momentum. So impulse equals change in momentum. And that's how we get to the impulse formula. Okay, the formula is here, and in terms of words, it's change in momentum. And this is called the impulse momentum principle. Now, this is a vector kind of quantity, a vector equation, so the direction will matter. Okay, so to keep that in mind when we start to look at some of the examples and some of the questions later on. Now, speaking of examples, let's look at the first one. So here I've got a body of mass 4 kilograms, initially at rest on a smooth horizontal plane. A horizontal force of magnitude 6.2 newtons acts on the body for 5 seconds. Find the magnitude of the impulse given to the body by the force. So let's look at that. So impulse, we know, is Ft, force times time. So that's 6.2 times 5, or 31 Newton seconds. And a Newton second is also kilograms meters per second, so you can write it like that, but Newton second is kind of preferred. Now the next bit is to find the final speed of the body. So for that we use the other impulse formula, which is change in momentum. So this is mv minus mu. Okay, so I know the impulse is 31, I know the mass is 4, and I don't know its final speed. And then I know the mass is 4 and its initial speed is 0 because it was at rest. So this means that 4v equals 31. So v is 7.75 meters per second. Okay, so that's the first example now on impulse and momentum, really, or change in momentum. But that's the impulse one. Okay, let's have a look at a slightly harder problem. So in this problem, we've got a ball of mass 0.2 kilograms, hits a fixed vertical wall at right angles with a speed of 3 meters per second, bounces off with a speed of 2.5 meters per second. Find the magnitude of the impulse exerted on the wall by the ball. So for this, I'll draw a quick little diagram to show you what's happening. So this is my wall, and my ball here is hitting the wall, and that's 0.25 kilograms there. Now going into the wall, it had a speed of 3 and leaving the wall, it had a speed of 2.5 meters per second. Okay, and then the impulse is here. And this is because the wall is fixed, so we can't apply the impulse momentum principle to it, because obviously it has no velocity, it's fixed. So instead we find the magnitude of the impulse exerted on the ball by the wall. Okay, and then use Newton's third law to deduce that the magnitude of the impulse exerted on the wall by the ball would be the same. So that's what we're trying to do here. Now, I'm going to basically resolve, using that word that we talked about with forces, but same kind of thing. So I'm looking at the left being the positive direction, because I've got is going left, and then this will be going left, and this will be a negative value. So the impulse is going to be the final 0.25 times the final velocity, which is 2.5, minus 0.25 times the initial velocity, which will be -3. Okay, because direction does matter. So this is 0.625 plus 0.75. And then that is 1.375 Newton seconds. So now I can say, therefore, by Newton's third law, the magnitude, and I'm just copying now out of the question, of the impulse exerted by the wall on the ball is 1.375 Newton seconds. Okay, so all I'm doing now, I've clearly shown I've worked out the impulse exerted on the ball by the wall. Okay, the wall's exerting that impulse in that direction, because that's the direction the ball will move after it's hit the wall. Okay, and then by Newton's third law, the other way round must be exactly the same force, isn't it? Equal and opposite force. So that is the second example, and that's about as complicated as it's going to get today in this video. So before we look at the questions, if you are yet to subscribe, hit that subscribe button now. I really appreciate it. If you found this initial video useful, hit that like button, and if you're willing and able to help me out financially, hit that join button. Otherwise, let's look at the questions. So I've got 3 questions for you today. The first one is a nice little warm-up question. Question 2 and question 3 are taken from past papers. Okay, so just parts of past paper questions there. So just 3 questions. So pause the video now. Okay, welcome back. Let's look at now the solutions to these 3 questions. So part A, the magnitude of the impulse is Ft, and the force acts at 8 newtons for 4 seconds. So that is 32 Newton seconds there. And then B, the final speed of the body is initially at rest. So we've got impulse equals change in momentum. And this is 5v minus 5 times 0, and the impulse is 32. So 5v equals 32. So the velocity is 6.4 meters per second. There. So that was the first one. Nice, straightforward warm-up question. Let's look at now number 2. So this is taken from a past paper, and the ball is of mass 0.2 kilograms, moving along a horizontal surface, hits a fixed vertical wall at right angles. So I'm just going to sketch that. So horizontal surface hits a fixed vertical wall, like so. So we've got the wall and the horizontal surface, and the ball is hitting that wall, and the ball is 0.2. Now the ball rebounds at right angles with speed 3.5 meters per second. So 3.5 meters per second there. And given that the magnitude of the impulse exerted on the ball by the wall, so this impulse here is 2 Newton seconds. Find the speed of the ball just before it hits the wall. Okay, so we want its initial velocity u. So impulse equals change in momentum. The impulse is 2. The final velocity is 3.5, so that is 0.2 times 3.5, and then the initial velocity is what we're trying to find. Now, this u here will actually be a minus u, because I'm taking left as the positive direction. Okay, so we've got 2 equals 0.7 plus 0.2 u. So this is 1.3 equals 0.2 u. So u equals 6.5 meters per second. So the velocity just before it hits the wall is 6.5 meters per second. And I just finished it off with a little sentence just to describe that. Okay, so that was question 2. Let's have a look at number 3. So this one, we've got another ball, same size, 0.2 kilograms, is dropped from a height of 2.5 meters above the horizontal. After hitting the ground, it bounces to a height of 1.8 meters. Find the magnitude of the impulse received by the ball from the ground. So I haven't been given any velocities in this one. So let's go ahead and work them out. So starting initially, the ball is dropped from a height of 2.5 meters. Okay, and then it bounces up to a height of 1.8 meters. But let's deal with the dropping first. So u is going to be 0. V is going to be the velocity I want to find just before it hits the ground. So that is what I'm looking at. A is, well, if I'm taking down as positive, A is going to be G. And then S, the distance is 2.5. So we want V, U, A, and S. So that is V squared equals U squared plus 2AS. So V squared is what I'm trying to find. U is 0 plus 2G times 2.5. So V squared equals 49. So V is 7 meters per second. So that then will give me the initial velocity for when I'm finding my momentum for my impulse. Okay, now we need to find the final velocity. So I'm just going to do another quick sketch. Don't really need to sketch here, but this time we're going up as far as 1.8 meters and the ball is bouncing up. So I'm going to take up as positive in this case. This initial velocity is what we want to find. So the initial velocity here is what we want to find. The final velocity is obviously 0. The acceleration now is negative g because g is acting down, and s is 1.8. So we've got the same letters, so it's going to be a v squared equals u squared plus 2as again. And this time we've got v squared is 0, u squared we want to find, plus 2 times minus g times 1.8. So that will give me u squared is 35.28. Obviously this being negative, take to the other side, it will be positive. Square rooting that answer gives me 5.939 and so on. I'll just put it as 5.9 to two significant figures, but I'll store the whole answer in my calculator. Now we need to go ahead and work out the impulse. So if I think of my diagram here, the ball is hitting this ground and it's 0.2. The impulse here is acting up. This is my ground. Now this velocity here is 7 and this velocity is that 5.9. So impulse is the change in momentum, and I'm going to be taking upwards as positive because that's the way my impulse is pointing. So this is final velocity, so 0.2 times 5.9 minus 0.2 times minus 7. So 0.2 times 5.9 plus 0.2 times minus 7. The two minuses there, turning this into a plus sign. So that gives me 2.58793 and so on. So 2.59 Newton seconds to 3 significant figures there. And there we have the last of the questions. Hopefully you found this video useful and you were able to do these 3 questions. Of course, you can have a go at a few more in your textbooks or online if you want to practice a little bit more. Otherwise, stay tuned for the next video, which is on the conservation of momentum. And that's coming next. And as always, like, subscribe, join if you haven't done any of these so far and you feel like. As always, no pressure. Anyway, see you in the next one.